Trees tutorial for full stack developers. Introduction. A tree is a hierarchical data structure consisting of nodes connected through parent-child relationships. Trees are one of the most important data structures used in check front-end applications, back-end systems, databases, file systems, search engines, cloud-native applications, compilers, distributed systems. A common interview question is, what is a tree and where is it used in real-world applications? This guide explains tree fundamentals, tree terminology, tree traversal algorithms, binary trees, binary search trees, balanced trees, heaps, tries, real-world applications, interview questions, best practices. This is one of the most important data structures for full-stack developers. Simple definition. A tree is a nonlinear hierarchical data structure where nodes are connected in parent-child relationships. Unlike arrays, 1 means 2 means 3 means 4. Trees look like A/BCE. Why trees matter. Trees help organize data efficiently. Without trees, searching becomes slower. Hierarchical data becomes difficult to manage. Databases become less efficient. Trees enable check fast searching, check hierarchical storage, check scalable indexing. Tree terminology. Consider A, O, B, C, L, D, E, root, top node, a parent, a node above another node. Example: A, down, B. A is parent of B. Child. A node below another node. Example: B, D. D is child of B. Leaf node. Node with no children. Example: D, E, C subtree. A smaller tree inside a tree. Example: B, F, D, E height. Longest path from root to leaf. Example: A means B means D. Height equals 2. Tree node structure. Java example: class tree node. Int value. Tree node left. Tree node right. Public tree node int value. This value equals value. Binary tree. A binary tree allows maximum 2 children per node. Example: $10, $5, $20. Full binary tree. Every node has 0 children or 2 children. Example: 1 bar 2 3. Complete binary tree. All levels are filled except possibly the last. Example: 1 MO 2 3 MO 4 5. Perfect binary tree. Every level completely filled. Example: 1/2, 3/2, 4 5 6 7. Binary search tree. Very important interview topic. Rule: left, root, right. Example: 50 25 75 10 30 60 90. Why BST is useful. Search complexity. Average: O log n. Compared to array search, ON, BST search example. Search for 60 steps. 50 means right. 75 means left. 60 found. Fast lookup. BST. Insert example. Insert 40. Result: 50 divided by 25 75. 10 30 40. Tree traversal. Traversal means visiting every node. Very common interview topic. Depth first search. DFS. Visits deeper nodes first. 3 types: pre-order, in-order, post-order. Pre-order traversal. Order. Root means left, means right. Example: A, avenue, B, C. Output: A, B, C. Java. Void pre-order tree node node. If node equals null, return system out println node value. Pre-order node.left. Pre-order node.right. In order traversal. Order. Left means root, means right. BST example. 10, 25, 30, 50, 60, 75, 90. Produces sorted output. Very important interview point. Post-order traversal. Order. Left means right, means root. Used for deletion, cleanup operations. Breadth first search. BFS. Visits level by level. Example. A, B, C, D, E. Output. A, B, C, D, E. Uses. Q. BFS example. Java. Q tree node Q is new linked list Q. Tree complexity operation BST. Average search O log n. Insert O log n. Worst case O n. If tree becomes unbalanced. Balanced trees. Balanced trees maintain. Height equals log n. Examples. Cap. AVL tree. Cap. Red-black tree. Benefits. Celebrated. AVL tree. Self-balancing BST. Example. Unbalanced 10, 20, 30. AVL performs rotations. Result. 20/10, 30, red-black tree. Used internally by Java tree map, Java tree set. Benefits. Automatic balancing, efficient search, heap tree, special binary tree. Types. Max heap, min heap. Max heap. Parent is always larger. Example. 100 divided with 80, 60. Used in priority queues, scheduling systems. Java. Priority queue integer trie tree. Very important for full stack developers. Used for check autocomplete, check search engines, check API routing. Example. Car, cat, call. Try. C-A-T, try. Applications. Examples. Google search. IDE autocomplete. DNS lookup. API gateways. Trees in databases. Databases heavily use trees. Examples. ACK, PostgreSQL, MySQL, Oracle. Use. B-trees. B-tree example database query. B-tree index. Fast record lookup. Benefits. Scalable indexing. Fewer disk reads. Trees in file systems. Operating systems organize files as trees. Example. Root, documents, downloads, pictures. Used by Fix, Windows, 6, Linux, 6, macOS. Trees in front-end development. React component hierarchy. App, sidebar, content, DOM itself is a tree. Trees in back-end development. Examples. Category hierarchies, categorization structures, category permissions, categories menus. Example. Admin, user management, orders, reports, trees in cloud-native systems. Examples. Kubernetes resources, DNS, distributed routing. Example. Cluster, namespace, deployment, pod. Real-world example. Example. E-commerce categories, electronics, phones, laptops, cameras. API. Get/categories. Backend. Category, child categories. Database. ID, parent ID, name. Common interview questions. 1. What is a tree? A hierarchical data structure consisting of nodes connected by parent-child relationships. 2. Difference between tree and graph. Tree, graph. No cycles, cycles possible. Single root, multiple roots possible. Hierarchical, flexible connections. 3. What is BST? A binary search tree maintains left, root, right for. Why is in-order traversal important? In a BST, In-order traversal produces sorted output. 5. What is a trie? A trie is a prefix tree used for efficient string searching and autocomplete. Common beginner mistakes. 1. Forgetting base cases. Recursive traversal causes stack overflow. 2. Confusing BFS and DFS. Different traversal strategies. 3. Ignoring tree balance. Unbalanced trees become slow. 4. Using BST for everything. Sometimes HashMap performs better. 5. Poor recursive logic. Common source of bugs. Best practices. 1. Master DFS and BFS. 2. Understand BST operations. 3. Recursive thinking. Practice tree traversals. 4. Understand balanced trees. 5. Know database tree and tries. 6. Understand real-world use cases. Optimize recursive solutions. And visualize trees when solving problems. Tree cheat sheet. Tree type. Common usage. Binary tree, general hierarchy. BST, fast searching. AVL tree, balanced searching. Red-black tree, Java collections. Heap, priority queues. Trie autocomplete. B-tree, database indexes. Full-stack tree architecture. Front-end, React DOM tree. Back-end, category tree. Database, B-tree index. Cloud, Kubernetes resource tree. Final summary. Trees are one of the most important data structures in software engineering. Important concepts include binary trees, binary search trees, DFS, BFS, AVL trees, red-black trees, heaps, tries, B-trees. Trees are used in C. React applications, Spring Boot applications, databases, operating systems, cloud-native platforms, search engines. Key idea. Trees provide efficient hierarchical organization, fast searching, scalable indexing, and are fundamental to modern full-stack application development.